Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. It's day 15. Welcome. It's so important that you showed up. Above everything else, the fact that you carved out the time for yourself today to engage in something interesting, that's what matters. So remember, what I do up here is how I'm exploring my 28-day journey to Phi, and it's supposed to be an inspiration to you. By no means are you expected to copycat me or get everything that I get. Remember, I have been in love with math for most of my life. Since kindergarten, I would say. Maybe even before, picking up pine cones in the yard. So I have a very positive relationship with math my entire life. Some of you may relate to me. Some of you may say, wow, that's not me at all. So what's most important on this 28-day journey to finding Phi is you finding your connection to math in a positive way with others, with yourself, and with nature, okay? So my creative output for my pine cone, which I believe is in the golden ratio, which is what this whole journey is about, exploring the golden ratio. The golden ratio. And middle school is all about ratios, but after middle school and before middle school, we deal with a lot of ratios. So remember, if you're on this journey, it's very important to have someone to go along with you, whether it's your kindergartner brother or your senior sister or your mom or your uncle or your grandpa. Just make sure that they can communicate. Doesn't need to be with words, but make sure that you can have a conversation with this person that's joining the journey with you. Like Canella, my big dog right here. Let's see if I can adjust. Oh, I can't. I wish I could show you her, but I don't have a camera yet. I'm still streaming from my laptop. But thanks to my dad and my mom, my parents, who really hooked me up with all this equipment to bring you an e-learning adventure. I couldn't do it alone, so I'm relying on my community to bring this to you. You need to rely on your community to make this worth it, to make this a journey that you will remember and that you can learn from. That's the intro part of today's lesson. The pep talk, right? Day 15, setting goals. So this is where we left off yesterday with getting organized. And again, yesterday you might have thought to yourself, wow, we're supposed to get organized today? And I think Miss Flynn made me a little bit less organized. I'm a little more confused. I was just getting the hang of Phi, and now she's talking about three-dimensional Phi? What in the world? Well, those of you that are historians, today is your day, okay? This week is your week. If you are interested in the ancient Egyptians, now is the time to really connect to Phi, because for some amazing apparent reason, the Egyptians used Phi to build the Pyramid of Giza. Right triangle, Phi, all of that. So, without further ado, let's get activated. Let's activate. And how I want to activate with you all today is I want you to estimate how much should I sell these cookies for? I'm not really selling them, but how much should I sell these cookies for? I baked them because I asked a bunch of people, what should I do my next series on after Phi? And they said baking, okay? I also am super inspired by Eugenia Chang, this book about how to bake pie. It's all about math. So my next series is going to be on baking. And to activate, I want you to think about how much should, if Miss Flynn went into the cookie selling industry, which I'm not, how much should I sell these cookies for? That's your activator. How much should I sell these cookies for? Now to help you out, now that you're thinking about it, I'm going to list the ingredients for you. So how much should Miss Flynn sell these cookies for? What information do you need to figure out how much she should sell these cookies for? Well, how many are there? What ingredients went into them? Here we go. All right. So let's zoom in. Okay, it's not a great quality image, but I made these in my dehydrator. 2 bananas, 1 apple, 1 carrot, 12 ounces of soaked dates, a half tablespoon is 1 part So 20 half tablespoons of coconut flakes, 20 half tablespoons of oats, 10 half tablespoons of cashews, 10 half tablespoons of sunflower seeds, 1 half teaspoon of vanilla extract, 2 half teaspoons of chia, and 2 half teaspoons of ground flax. How much should I sell these for? Share with somebody around you. I can't hear you, right? That's the huge difference between learning with me live on YouTube and me teaching you in the classroom, is that you need to find the person to talk to. It's not me telling you right or wrong. It's you engaging in a conversation about ideas and topics I pose to you, okay? Well, I hope you activated. I'm interested to hearing what you think I should sell these cookies for. Please comment or email me. You can comment on muddymath.com on day 15, organize, or you can send me an email, or you can post in our Google Classrooms if you're my current students. So how much should Ms. Flynn sell these dehydrated crackers for? All right, let's get started with organize now that we've activated our minds. A friendly, no right, wrong answer activity to activate our minds. Now let us talk about goals. So if you go to my website, okay, muddymath.com, you'll see the PDF enhancements for today's lesson, and also my notes on how I kind of looked at these very important keywords that we need to learn to be successful. So I did not change the no words that we are supposed to learn today. I did add one, which isn't on this list, unfortunately, but I added the word net, okay? So yesterday we got organized, so it looks like I have the old understand from yesterday. So yesterday we organized everything we learned to take on a new perspective, the three-dimensionality of phi, and we modeled it with a pyramid, okay? And then these are the blank notes with the isometric grid, and we get to investigate using a coordinate plane as a tool, an isometric grid as a tool, the benefits and the setbacks of using these different sort of mapping paper tools. And then we also, I'm like polar coordinates, looking at the coordinate grid, but not in terms of squares, but in terms of polar coordinates. Again, discern, where does this information meet you? Where is your learning moment? Let everything else pass over your head, and then the moment you meet your learning opportunity, that's where you dive in. And you don't have to follow the video exactly what I'm doing, and if something inspires you, your curiosity, dive into it, okay? So these are isometric grids. So what I want to do today is touch on the words that we didn't get to yesterday, all right? So we talked about a pyramid yesterday, and this shape is super important in building the Egyptian society. They used pyramids. We build it sort of in like cubes, rectilinear houses. Okay, we got disconnected there for a second. Now we're reconnected, so let's... All right, we're reconnected. So a square pyramid, what I drew here in my notes, and you have access to these on muddymath.com, is a net of a square pyramid. And how can this help us understand phi? So before we really build a pyramid three-dimensionally, let's look at how we can do that. So if you have a piece of paper, okay, get that now. I'll give you a minute to get a big piece of paper or a small piece of paper, whatever. So please get a piece of paper, okay? And it's okay if I'm not even going to use scissors or anything. I'm just going to tear it because I want everyone to have access to this activity. So you need something to write with and a piece of paper. We're going to build a net of a square pyramid and do our best to build it with phi, okay, with the beautiful ratio of phi. So get a piece of paper, okay, and a piece of something to write with. Okay, maybe a raspberry in your fridge is all you're going to use to write with, and you're going to smudge the raspberry all over the paper. No, that's not very precise. But get a piece of paper and a pencil or a pen. If you have measuring tools, okay, they'd be great to use. So, for example, I have a measuring tape. I also have this beautiful bullseye compass that my dad got me. Ooh, ooh. So get a piece of paper, get a piece of measuring, get some pencils to write with, okay? I'm actually going to use a marker so it's nice and easy for you all to see. And let's build a net of a square pyramid. Now we know from yesterday that we need a circle of a radius 1 to determine the squareness of our base of our pyramid. Okay, in 3D, the big base of the pyramid needs to be one square made by the unit circle. Again, I'm not going to use all my fancy tools here because I want you all to have access to this activity at home with just a piece of paper and something to write with. So let me bring this closer, okay? And behind you see is some of the notes we took yesterday, but we're trying to kind of reconstruct what we see on the isometric sketching paper, okay, but on a bird's eye view. So the bottom here, it says bird's eye view, and that's looking straight down, and then using the isometric grids, it's kind of on an angle, like if you were looking at it from a standing point versus like over top. So we're going to do the bird's eye view here, and to make a circle, okay, one way I like to make a circle is use my hand as a compass. So to use my hand as a compass, I'm going to use this part of this bone on my, connecting my wrist to my hand, and that's going to be the center of my circle, and then I'm going to fix my pen in a certain spot. So this is just like a compass, and I'm going to go kind of small, and then I'm just turning my paper. Okay, and it's not perfect by any means. You can definitely tell that this is not a circle because the radius is changing, much like my dad used to say when he was teaching me how to drive, that off-ramps and on-ramps with an increasing radius are dangerous. Shout out to my dad. But anyway, you can see here that from this distance is much shorter than that distance. So it's not a perfect circle. So, you know, I can try again, or I can embrace my mistakes. I'm going to try again just to show you, like, that mistakes are struggle points that help us learn, and that's okay, and that's a moment to stop and say, all right, let me try again and push through this struggle moment. Okay, so here we go. You can try it again with me. Set the center point of your circle by marking a dot. Put that bone on the center point of the circle. Fix your pen or marker in one spot, and then spin your paper around so that hopefully all the points on your circle are the same distance from the center. Try to move any objects out of the way of the paper, like you see me struggling with my magnets. There we go. Now that's much better. That's a much better circle. Okay, but now this one's way too large. I'm not going to be able to draw a net on here. So again, I'm going to try again. Beauty, right? Mistakes help us learn. So I'm going to try to make my radius smaller, maybe inch down to the edge of my pen. And I hope you all are just trying to draw a circle. Draw a circle using the bone of your hand. Okay? Adjust the marker in a way that it touches the paper and you don't have to move it. So that hopefully when you spin your paper, all the points on the circle are equidistant, the same distance from the center point, because that's the definition of a circle, is the set of points that are all the same distance from a single center point. Okay, it is not a polygon, it doesn't have corners or straight lines. So this is the circle I'm going to work with. This is going to be a circle of radius equaling 1 unit, okay? I'm going to bring it closer. There we go. Okay. So now I'm inscribing a square. No, I'm sorry. The circle is going to inscribe a square. So what I want to do is try to draw a square around my circle so that I know the length of my square must equal the diameter of the circle. So if the radius of the circle is 1, then the diameter of the circle is 2. Okay, so I'm going to let you catch up there. So what we're doing is we're trying to build the Pyramid of Giza. Ooh, the Pyramid of Giza. Pyramid of Giza. We're trying to build the Pyramid of Giza with a piece of paper. Okay, and we saw from goldennumber.net that the Pyramid of Giza is likely formed using the golden ratio. So how do we build the golden ratio out of a square with the unit circle inside? Well, remember, we use the Pythagorean Theorem. And those of you that are like, Pythagorean, what? Okay, just know that we can form a right triangle. Okay, let's just draw a quick sketch up here. A right triangle that has a base of 1, okay, and then the square root of phi and phi on the other two sides of the triangle. So which one goes where? Well, the hypotenuse is the longest side, so that's going to be phi, okay, 1.618, about, okay, and then the leg has to be shorter than the hypotenuse, so that's going to be smaller, the square root of phi. Now, if you have a smartphone, okay, the calculator function, if you turn it sideways, okay, you can get a lot more operations and functions here. So what if I type in 1.618, which is our approximation of pi. This is our rational approximation of pi. Remember, our irrational approximation of pi is the square root of 5 plus 1 divided by 2. And then if you see this button over here, if you have an iPhone, sorry if you have an Android, but if you see this button over here, third down, second in, that's the square root function, okay, the operation square root. So I'm just going to press that, and that gives me the approximate value that if I multiplied 1.27 by 1.27, I would get phi. So the square root function is something else that we're learning about, and I have notes on that. Right? The square root is something that we use, okay, whatever goes under the radicand is what we're trying to find, two factors that are equal, that when we multiply them together, we get that number. Okay, so the square root of phi, the number that is approximately equal to the square root of phi, is about 1.27. So it's pretty fascinating here because when we do use the Pythagorean theorem, okay, it's not true, even if we use some approximations that we think are close to the golden ratio, like here we use 10 squared plus the square root of 16 squared, they're not even close to being equal. 116 does not equal 256. But if you look in the top left corner, when we actually use phi, it comes out to be the same thing. So this is a fascinating ratio where the square root of a value plus 1 equals the value you took the square root of squared. It's crazy. Again, if that is like, whoa, too much, then you just step back and you're like, okay, let me just listen, it's interesting, but don't stress out about understanding it. Find the limit of your understanding, which might just be drawing a right triangle, or you could still be focused on drawing a circle with a square. Remember, this is a broadcast to every human in the whole wide world, right? So there's no way I can possibly, one, get a taste of what you need. We don't have live comments because this is YouTube Kids, and there's no right or wrong. So you need to grasp the limit of your understanding, embrace it, and push through there. So I'm just trying to show you all these crazy access points, okay? So anyway, our goal today, goals. Yeah, come on, Sam, Miss Flynn, however I call you. It's goals. Yesterday was organized. I didn't get organized. Today's goals. I'm not meeting my goal. The beauty of goals is that it's the journey towards the goal that's the candy, as Adrian says. It's what Kobe Bryant was once quoted about, was saying how you set these goals and you may or may not meet them, but when you look back, the process towards the goal is what mattered the most. It's the memories. That's the learning. So our goal is to build a paper version of the Pyramid of Giza, because apparently in ancient Egypt, the Pyramid of Giza was built using the golden ratio. And more on that, how they did that. Like, how did they be so precise without, machines and stuff? So anyway, I digress. Back to this. I hope I gave you enough time to build your unit circle and a square around it. So if this is 1, we need to determine what phi is, right? So in the past, we've used that since phi is approximately equal to 1.618, right? Then all we would need to do is add on about 61.8% of this distance to make phi. So one way we can do that is break this into 10 equal pieces. So cut it in half and that's 5/10 on either side of that line. Okay, find the middle, and that would be a quarter, but I don't want quarters, I want tenths, so I'm going to go a little to the left and a little to the right to make 2/10, 3/10, 4/10, 5/10. So I'm going to do that again. Creating equal intervals is a skill that I've talked about in this journey before, and it's something you need a lot of practice with. And take your time and breathe and try again. Try again, try again, find your struggle point, try again. It's drawing a number line. You can do it for 10 minutes. Try to make it nice and equal intervals. That is a skill. That's a math skill. Woo. Oh, I should scroll back up. Oh, no, this is good. So you see this little diagram in the bottom left-hand corner. That's how I can use the irrational approximation of pi using sort of geometric constructions to actually show the square root of 5 plus 1 divided by 2. But we're going to use a different way. That's a more advanced way if you're comfortable with square roots and radicals and things like that and irrational numbers. Here I'm just going to say I want about 61.8%, so I'm going to round that to about 60% of this, what we're defining as 1. We need 60% of that. So again, this is the halfway mark. This is 50%. Okay, to get 60%, it's going to be about right here. Because halfway is 75, a little to the left is 70, a little to the right of 75 is 80, 90, and then we get to 100. Okay, so 60% of that line is that much. Oh, not very precise, right? So if you have some sort of measuring tool, like I have this measuring tape for when I sew. Yes, I sew. I can use inches, right? And so I see that my unit is about, I would say 1 inch and 1, 2, 3, 4, 5 out of 8. 1 inch and 5/8. So my unit, right, talking about scale, that's 1. 1 unit is 1 and, what did I say? 5/8 of an inch. Okay, so then 60% of that looks like it's about 60% of 1 unit should be equal to 0.6 units. Okay, but let's check to make sure we're accurate. So I can use a calculator to see if my approximation is good enough. So I'm looking for 1 and 5/8 of an inch, 60% of 1 and 5/8 of an inch, 60% of 1 and 5/8 should be about 7/8. Let's see if I'm good. Let's see if that works. So to put this into a calculator, okay, I'm going to do 5/8 first because I need to respect order of operations, and then add the 1. 1 and 5/8 is 1.625, and then multiply it by 0.6 to get 60% of that. So I have that 60% of that is 0.975. Let's figure out what 7/8 is. 0.875. Pretty close for me, just eyeballing it, right, and using a measuring tape like this. So that works for me. So what we want to do is we want to make the angle, the hypotenuse of this pyramid to be phi. So three-dimensionally, where does that line match up? Well, the slant height of the pyramid connects to this point, right? So if I was imagining it in 3 dimensions, the slant height would come up here and then connect, the height of the pyramid would come straight down. So the slant height is that distance from the center of the edge up to the apex, and then the height of the pyramid is straight up from the center of the pyramid to the apex. So if I were to unfold that, where would that distance be? Right, it's this distance straight up out from the center. So I'm going to add on this 60% right about there. Okay, now that is phi, but now I need one more because that whole distance. So that right there is a phi distance out from the edge of the base. So I need to replicate that. Again, we're just sketching here. I'm scratching my paper using my hand as a compass and scratching my paper because it's just a sketch to figure out about phi distance out from the edge of the square, the base of the pyramid. Boom. And then again, down here. Boom. Okay? And that's the last of the calculations we need to do. Now we just need to draw the triangles. These are called isosceles triangles because these two side lengths are equal. Okay? Now the heights of all of these isosceles triangles are phi. And then if you understand the Pythagorean Theorem, you'll see that if this is 1, 1, 1, 1, 1, 1, 1, 1, because that is that distance formed by the unit circle, that these hypotenuses, are all square root of phi. Okay, so we have our net. We have about 2 minutes left. Let's try to meet our goal of using a net to build a 3D pyramid. So one way you can do this is fold along the edges and really crease them down with your finger. Okay? So those of you that don't have scissors at home, this is a really a good strategy to use. I'm just really creasing the edges of my pyramid with my fingernails, or you could use the side of a piece of a table that's flat, okay? And then I'm just going to tear. Once I have all these creases in, I'm just going to tear my paper and see if I can form my own Pyramid of Giza. Giza, like the ancient Egyptians, but we're going to look a little bit deeper into how they could have possibly done that, you know, without all this knowledge we have. So another way to do it is to help it tear by adding a little moisture. Get a little sponge, let's say, and tear it after sponging. Okay, so I really, while I'm tearing, like, I made a mistake. It's okay. If you wanted to be super precise, you could go get scissors. I guess I should have been more prepared and grabbed scissors, but again, not everyone has scissors. So I'm just trying to tear it. It doesn't have to be perfect. Remember, you need to find people to join you on this journey, okay? The huge component you all are missing out from when you're learning at home is each other, okay? So whether it's your cousin, your neighbor, your best friend via technology, okay, find someone to talk to about this. It's uncomfortable at first. You guys aren't used to really like chatting about, oh, the Great Pyramid of Giza was formed by phi, but what a cool opportunity to have scholarly conversations and taking your education seriously at whatever age you're embracing this challenge, okay? So here's my 30-minute mark. I don't often, like, I'm not putting a time limit on me, but I think I should be able to get my job done in 30 minutes. Dun, da, 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 the Pyramid of Giza. Ooh, 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 ooh. Pyramid of Giza. Using phi, the golden ratio, 3 dimensions. Look at mine. It's like funky, not like perfect, but the beauty of it is the process, right? And if I practice once with tearing and getting a crazy model that doesn't look perfect, okay, then I can advance and advance and advance and only push up to your understanding. Struggle is good. Remember, we celebrate the struggle, because you're going to struggle at home by yourself, or hopefully not by yourself, but if you are by yourself, you're going to struggle a little bit, and that's the learning moment. You press up against your understanding, and you embrace it, and then talk about it, and listen to others' ideas. So comment on muddymath.com, comment in our Google Classrooms, reach out to others. You have to work to socialize with distance to learn. It's very important. I'm very serious about that. You need to collaborate. I'm here for you. It's send me an email at muddymath@gmail.com, or if you're one of my current students, through our school's emails, and embrace our 28 days to finding phi. Day 15 in the books. See you tomorrow. Signing off.